can you have a calculator? No, that's lame. Who needs a calculator? We'll take away all temptation. Basically, let me give you a quick rundown of the quiz just so you know it before we even go through. You need to know summer packet from last year, aka algebraic stuff, like, you ready? You might want to, have a writing utensil. Like complex fractions. Ooh. Horizontal, vertical asymptotes. Limits to infinity, discontinuities. Unit circle. Am I going too fast? Did we catch up? Number 2? Well, we kind of had a few different ones. I said complex fractions, asymptotes, horizontal/vertical. Then hint, hint, limits to infinity. Not sure if that's a hint. It is in my mind, but unit circle, lines. Ooh, lines. Exponential, logarithmic stuff, not calculus stuff, though. You're not going to have to derive or integrate exponential log. No, no, no. More like pre-cal simplifying stuff. Domain. Limits. Do I want to give a hint on those? No, you're allowed to use L'Hopital's, but that's only when it's indeterminate, aka or. So what else could happen to a limit besides 0 over 0 or infinity over infinity? Number over 0, or just nice plug in and you're done. Now, the nice plug in and you're done, well, sometimes it's too easy, but it's easy, right? Number over 0. What's going on? Not a whole. That's 0 over 0 when it can't factor. It's an asymptote. If it's number over 0, it's an asymptote. If it's an asymptote, what happens is we come into an asymptote. Either or, so you have to check the well, 50% chance as long as you get the right case. Anyway, so limit 0 over 0, number over 0, or plug in and it's nice. If it's 0 over 0, yes, you can use L'Hopital's. Or you can use factoring or multiplying by the conjugate or any of those fun things from before. Derivatives. I'll just leave it there. And extrema. You guys tell me, what do you know about extrema? Minimum, maximum. Or relative. It won't be absolute. I won't be that mean.
For derivatives, is that like all of their semester? Or just like basic?
I did say no exponential logarithmic derivatives. That's nicer. Which I think keeps it in the more basic camp, but including chain rule. Basic.
When you said lines, do you mean like coming up with an equation for a line, or?
In some way, shape, or form. Yeah. Yeah. Not like linearization or approximation. Nothing like that. Oh, I could have done that. I could have had you use it to approximate. Nah, it's all right. Yeah.
So this is like, because our pack is like half a test. Is this the other half of the test, or is this like going in the second? I guess it's all in second. Okay. Does the packet go on the test?
Which is nice, because if your packet's done, then you already have 50 points out of the 100. What? Go team. And then the quiz will just add to the, and it's nice. And yes, there are bonus opportunities on the quiz. Okay, are we good at least on what we're needing for tomorrow? Okay. Now with that, with the informed, now that you are informed, that's a better way of putting it, let's go ahead and approach the summer packet and the questions you may have. Okay. Oh, orthogonal? Is it that one? No. Orthogonal has to do with perpendicular, and isn't that in vectors? When the dot product is 0, right? Then they're perpendicular? Physics. Anyway, so here we go. Guys, I mean, there's topics. It's not as nicely organized as it was last year in the sense of I just kind of give you problems. But since we talked about lines, I mean, that's basically the entire first 1 through 4. Any clarification on lines? No, we're good? Perpendicular, what do you do with slopes? Parallel, what do you do with slopes? Keep them the same. If it's in a weird, like, standard form, what do you better do first before you even think about slopes? Get them into, like, y equals mx plus b, something like that. What's the one form of a line that you should always be using? Yeah. Y minus y1 equals m times x minus x1. Good. Okay, next section. Everything to do with functions and compositions and inverses. Any questions that we have with functions and manipulating, working with them? Yeah. Number 8. Well, okay, notation-wise, hold on, first of all, 5 and 6, did anybody just for a second get confused about notation on 5 and 6? It's a little weird because it's not like f of -3 plus g of -3. This is shortcut notation from pre-cal. We haven't seen it in a long time. But once you realize it's not distribution exactly, but it's more like it's a composition, that it's f plus g of -3, not times. That would have totally messed you up. So it's f plus g of -3, which is f of -3. So anyway, that's just shortcut notation. That would have been a little confusing. But coming down in numbers 8 and number 10, whenever you see the little O, that's pre-cal for composition of. Good. Composition or of. So whenever you see this, you just have to think about the inner is the one on the right, the outer is the one on the left. So I love this notation so much more. Instead of G composition F, G of F. And all we're doing is we're taking, remember, the argument, which in this one would be f of x. We're making that entire function the argument, and then we're simplifying. Does that make sense? So it's a big old plug-in. Same thing here, we're taking g, big old plug-in, and then simplifying. The weird thing on this one is you weren't just plugging in g of x, you were plugging in g of 3. So we took g, plugged in 3, then plugged in, and then it's all simplifying. Why do I have a domain restriction? This is all real numbers. But it came from, and the original one included the square root function, and the square root function was limited to the argument greater than or equal to 0. Are we good? Okay. I said exponential logarithmic, but not derivatives. This is good as far as simplifying. Any simplifying questions that we had? We didn't really have to do a lot of this last year. What's the relationship between ln and e? They're inverses. Good. So they undo each other. Yeah. So whether it's ln of e, which none of these are. Oh, yeah. Whether it's ln of e, remember the 7 pops down, or whether it's e to the ln, why could I not just go 3x? The notation, the logarithm 3 times is really x cubed, and then the e and ln, I can now go ahead and properly say, oh, they are inverses, they undo each other, x cubed. Yeah. This is not just a simple multiplication. I can't just say e cubed power to a power. I would have to write it like this. And e cubed and ln, they're not inverses. E to the 1 and ln are inverses because this is ln log base e to the 1. That's why I can't just cancel out right now. But if I rearrange, if I see it as 3 ln of x, and I can then go ahead and make it e to the 1 to the ln of x cubed, now the base is matched and I can go. Anyway, that was random. Yeah. No? Were there any other logarithms in the packet besides right here? Oh, yeah. Good. Down here, because I was going to say there are more properties that are on the quiz tomorrow. So remember when you have a number multiply, pull it up. Remember addition, subtraction as far as the quotient property, a single logarithm of division, or the product property, a single logarithm of multiplication. And to undo exponential functions, we can do ln, or there's the really nifty, what was cool about 24 that made it so much easier?
Just make it 3 to the third.
You can make the bases match, and life is so much better. Do you remember from pre-cal the name of the property? That lets you jump from there to there without doing any math? The one-to-one property. Has to do with horizontal line test and invertible, and anyway, the one-to-one property. Yeah, go ahead. Yeah. Ooh, logistic growth. Did I skip this on the summer review live sessions? I might have. I apologize if I did. Logistic growth is going to be a big thing this year, but not as in supremely complicated. Just it's going to be important for the BC exam. Logistic growth, it's a special one from pre-cal that we saw just as much as, I mean, we didn't really memorize it, we didn't really do much with it besides the fact that it's exponential growth that levels off because the population is limited. I feel like we talked about it at some point last year. Maybe we didn't. I don't remember. What's an example? This is talking about elk, right? Okay. Elk. You have more elk, and they have more elk, and they have more elk, and they have more elk. Exponential growth. Why would that ever be limited? Yeah. Resources are limited, right? So the more elk, the more elk, the more elk, the less food, the less food, the less food, and then population is controlled. Usually population is controlled, unless you live in places like, what's something really green? Where was I this summer? North Carolina? Where they like have no limit on hunting licenses because they're like, please just get rid of these things because they're just pests at this point. It's crazy. Some guy went out and bagged like 30 deer? Something crazy like that. I was like, He gives it to shelters, and it's this whole thing. But anyway, depending on your environment, they might be able to grow for a lot longer than other environment, like Colorado. They're everywhere. But eventually, the environment can only sustain a certain population. So even though you have exponential growth, realistically, it's still going to be limited at some point. That's what's going on with logistic growth. It has this weird equation, which ends up basically, it's really spiffy, having, as long as it's in the right form, this top number, we call it L. It's always going to be the limit, which is kind of cool. But mathematically, you guys should have been able to figure that out, because if you're looking for the horizontal asymptote, you would need to take a limit to infinity. And as you take a limit to infinity, what's the only part of it that even has a t? But it's not normal exponential growth. It's not e to a positive exponent, it's e to a negative exponent. So if we were to rewrite it in a way that makes sense, like I would have hopefully somewhat drilled into your minds last year, even though it didn't look quite this weird, it'd be 75 over e to the 0.03t. So as you go to infinity, what's this going to? And what's the whole thing going to? 1216. So the bottom didn't win. The top one. Well, no. The bottom one of that little baby piece. That's a better way of putting it. I apologize. But yeah, so that went to 0. The whole thing went to. Was that what was going on in C? Yeah. Oh, hey, I rewrote it. Anyway, anything else as far as page whatever we are on? I don't know what number. Yes. Okay. Okay. Oh, Aryan, sorry.
Could you, what was the property behind number
26?
26?
Oh, change of base. Is there a way to not derivative, sorry. How to think of change of base formula? Yes, technically. And all of your like spiffy updated calculators, they let you do whatever base you want for a logarithm. But back in the olden days, or if you needed to simplify it and they weren't asking for a decimal, because they could have asked you to simplify it, or they could have made it match to something weird. I was just reminding you of the change of base formula, which is log base A of B is equal to log base C of b over log base c. That's what that is. Yeah. But you're right. Your guys' calculators didn't need that. And it was a calculator problem, so. But there you go. Okay. Good to keep going? Okay. Remember, you need to like have your face show what you're feeling. So if you're like, I need to see that, because if you're just like, oh, they're good. Yes.
One more question, actually, is number 28 going to be on
Or just raise your hand. Number,
28? Is that who first?
no. Oh, you want to memorize the interest formula? That's fun. Oh, okay. Just kidding. No. There's, the nice thing in calculus is besides specific functions, right, like exponential, logarithmic, trigonometric, besides functions that we need to know the behavior of, logistic growth gets added to that this year. There are no real, even exponential growth and decay, there are no real formulas you have to memorize and models you have to come up with on your own. That creative aspect of the higher maths is not included. So along with that, the interest formula, it would be given to you if you ever needed it. Unit circle, memorize, you guys know, yeah, please memorize. I do not believe I said anything about T-proofs on the quiz. Some of you didn't like the whole proving down here, but I like T-proofs. I enjoy T-proofs. It might come up a little bit more. Last year, the only time it really came up was when the derivative or the integral was so nasty. Oh, yeah, that comes up this year. Just kidding. When the derivative or the integral was so nasty that we couldn't take it as it was written and we had to transform it to another form to make it possible. That's going to come back this year, but not on the quiz tomorrow. We'll deal with it when it comes. Oh, hey, look. That's fun. What was nasty about this problem, though? Oh, go ahead, Kathy.
Okay, I was just wondering, could you manipulate both sides of the equation instead of
Proper form says no. Proper form says no because, well, not because. In our context in Calculus BC, the reason I would say don't go on both sides is because ultimately you're going to have an integrand and an integral. That's just going to be the nasty side, and the more you can simplify it, the easier your life will become. Or it's up to you to figure out which direction to simplify it. So all of this was kind of foundational to being like, hey, we'll tell you what it could be, see if you can make it work. So it was kind of like giving you a peek behind the curtain, whereas the problems we're going to see, you're not going to know what it simplifies to, so you're going to have to do the whole plane through the process. Does that make sense? So ultimately on the summer packet, like, it's okay if you did. It's not a bad thing. Because technically you can think like, oh, hey, it's 1 over sine. Oh, I'm going to do 1 over sine, then cosecant. But ultimately what you want is one, what am I trying to say? One, it's gone. It's okay. Complete transformation on one side rather than having to go back and forth. Put it like that. But good question, Kathy. I didn't have you for pre-cal, huh? That's why. Okay. Why was this one hard? The quiz is not going to be this bad because the quiz is going to be able to be done by and not. And why was this one bad? Because this was not factorable to be a nice rational zero. So I apologize. I should have given you a nice one. I need to change that in the summer packet. You had to ultimately go to your calculator, which was kind of lame and dumb. So know how to find maximums and minimums. Relative is my hint, I believe. Finding the derivative, factoring, finding the zeros will be sufficient. Does that make sense? You won't need your calculator to factor. Okay. What else? Anything on this page? Intersections. You're using your graphing calculator, which you're not doing tomorrow. Even odd is not on there. It probably should be, but it's not. Graphing piecewise was just seeing if you guys have lost all your skills or if, well, like, sorry, all your algebraic pre-cal graphing skills. Like, oh, it's a parabola. I can do that. Left of 0 and between 0 and 3, I can do a line, and greater than 3, I can do a, because that's something you could do on an AP. Like, you could actually get a picture of what's going on even if you can't use your calculator. Oh, nice. I like that one. That one's nice. Anything? Okay. Yeah. If you're looking at a graph, which you won't have tomorrow, like with domain and range, but if you're looking at a graph, remember domain just says how left, how right. How left does it go, how right does it go. Range says how low to how high. So once you have exponential function, negative is just a vertical reflection, then how left, negative infinity, how right, it might look like it has an asymptote, but you have to know exponential growth. Exponential growth goes forever. It just goes really fast, but there's no vertical asymptote, so it's going to keep on going forever. Domain, it never hits 0 because of that horizontal asymptote. But looking at the function, domain, you can see it's all real numbers because no square root, no logarithm, no radical, no weird trig function with asymptotes like tangent or cosecant, right? So domain's all real numbers. Range, you'd have to think of exponential growth equation. Ooh, it's limited, 0 to infinity, not including 0. Oh, it's flipped, negative infinity to 0, not 0. Yeah. 56, Riley? You guys help out. What does it mean to eliminate the parameter? I didn't have Riley for pre-calc. Well, I didn't have a lot of you, but a lot of you had Che, huh? Get rid of t. Eliminate, take out. Get rid of t. Well, how? It's in everything. Wait, what if I solve for t, substitute, all of a sudden t is no longer a parameter? Does that make sense? So it's this whole little process of basically how do I disregard time? Because as we're going to learn later on in the year, actually no, we're reviewing parametric right after we take the summer review quiz. That's right, and polar. Everything pre-cal. From only polar and parametric. So we'll review it more, but basically horizontal changing based on time, vertical changing based on time. Taking out time says what's the path. I don't care about the timing, just the path. Anything else on this page you guys want to see? Okay. A limit does not exist if coming towards a point, they disagree. A limit does not exist technically if there's no single constant, like it goes to infinity or negative infinity, but we still answer. And a limit does not exist if you have a function that's oscillating between two fixed points, or oscillating even in an infinite manner. Cosine will never approach one constant. That's the long story short. It'll approach, it'll just do its thing forever and ever and ever. It's never approaching a single constant, and we wouldn't ever be able to say anything like infinity or negative infinity. So he can never make up his mind, so we go ahead and just say DNE. It's more of a concept-y one. Yeah. Okay, because this is your example from the right from the left. First of all, from the right makes sense because of the positive. So whenever you have a positive, you think of the number and you think of numbers a little bit bigger than. If you had a negative, think of numbers a little bit less than. So this would be like 5.1, 5.01, 5.001. We're not plugging in because I can't do that in my head, right? But we look at the nature of the function and say, do I know who this guy is? The hope would be yes. The reality, I realize some of us are rusty. But a basic ln, inside shift, right 5. If we can get this picture, it makes all the difference of saying, okay, as I come in towards 5 from 10, from 6, from 5.1, 5.01, 5.001, negative infinity. It gets trickier when, remember your question from yesterday, when you have something like, oh, do we have another one? Hold on, that's the piecewise question. We have time. Let me get to, I changed my toolbar so I can actually click buttons. Okay, what if I was to do the limit as x approaches, how nasty do you guys want me to make it? Not nasty? Does that work? Okay. It's not 0 over 0. It's not infinity over infinity. It's not plug in, you're good. What happens when I plug in? Number over Okay. What does this point me to? Good. Infinite form. It's a positive or a negative infinity. That's not my answer. Those are my choices, right? Because it's a vertical asymptote. This is my infinite form, number over 0. Okay. So now, Hannah, now we need to think specifically, what do we got? From the left, 4.9, 4.99, 4.999. Does that make sense? Because of the little minus. Right now, plugging in 4.9 and squaring, I'm like, 4.99 squaring, But two ways of thinking about it. Some of you, depending on your brain, you can do what Maggie's doing and be like, hey, it's going to be smaller than 25. It's going to be a negative. Awesome. Positive over negative is negative infinity. Others of you, you're still stuck on the I can't square it and it has nasty decimals part. So what you can think of is the following. 10 over 2 times 5 is 10. No stress. 2 times 5 is 10, right? Then you can think of we're just checking signs. We know it's infinite. We know the bottom is growing stronger than the, I said that backwards. We know that number over 0, there's a vertical asymptote at 5. But check out the signs. What sign's on top? Always a positive. 4.9, 4.99, 4. It's a positive. Okay, got it. What if I did 4.9, 4.99 plus 5? Positive. I'm not thinking about the numeric value at all. What I'm thinking about is the sign. How about 4.9, 4.99, 4. Minus 5? A positive over a negative is. So what's my final answer? Without having to visualize the graph at all. Does that make sense? It's just playing with the numbers, knowing the pattern, knowing what's going on. Vertical asymptote, sweet, I know something's going on. I can kind of just test super close. If you want, you can visualize 4.9, 4.99, but don't go plugging in. Don't do decimals. Just try to think about the numeric values and positive or negative. Is that cool? Good. All right. Isa. Coming back. Go ahead. 60s. Oh, I thought I hit it. There we go. Thank you. Oops. Positive infinity, and here's why. When x is approaching infinity, technically we call it an end behavior model. I don't know if your teacher used that. An end behavior model. We're looking at the magnitudes. We have a quadratic over a linear. And so in that division, as x values increase without bound, the top wins is what I would say. The magnitude of the numerator is greater. So as x grows, even though you have this, ultimately the end behavior of this model is going to be negative x. No, positive x. We didn't do end behavior models. I apologize. I'm trying to do it in a different way than we normally do. What I would normally say is top wins. Whenever the magnitude of the numerator wins, we always know it's going to be plus or minus infinity. Then we have to check the sign. But as we check the sign, did I check the sign? Maybe I didn't check the sign. Well, you have to think about, you can do it a couple different ways. The way I probably would have done it, and this is the way I should have done it, and I didn't show it at all, is I would have pulled out the negative. I just went fast. I don't even think I checked the sign. Because now at this point, if you plug in, I mean, you can imagine 10,000, 10 million, 1 trillion if you want to think the numerical approach. And as you do that, the top wins, but where are you going? Did anybody else catch it? Did anybody even ask me that question on the packet? Struggle. So negative infinity, be proper. Was that your question? Oh. You were asking 0, right? You could. That's the way you guys did it. And if you divide by x squared, you would get he's breaking down the magnitude to see what's left. And so we would end up with this approaching 0. We did it once last year, you silly goofs. 0. But this is 1. Got it. Got it. Yeah.
Can you do 65? Actually, I don't understand why sine 3x. You can cancel out the 3x and the sine with the 3x.
Because the property, the special trig limit, which ultimately you could go back to L'Hopital's, because you could take a derivative cosine and then over, and you could plug in. Ultimately, because of L'Hopital's, the limit as u goes to 0 of sine of u over u, whatever it is, sine of 3x over 3x, sine of 7x over 7x, sine of x plus 1 over x plus 1, as x approaches 1. As u goes to 0, sine of u over u, the limit will always be 1. So I did a quick L'Hopital's, or I just used forever card number, whoever he was. Yeah. Good question, though. Piecewise. Okay, good. Limits. This comes in both Hannah's question and Maggie's question, and Isa, you were the one that pointed it out a second ago. Less than or equal to 3. Number line, 3. Less than or equal to. Aren't those numbers below 3? Right? 2.9, 2.99, 2. I mean, a lot more, but. So this is the below 3, and this is the above 3, and then this one is also below and at 3. Just thinking about inequalities, right? So if I'm coming from numbers below 3, I'm looking at only this portion. If I'm looking at numbers above 3, so as x approaches 3 from above, then I'd be looking only at that portion. If they were asking me for f of 3, I'd be looking at this portion. So I can literally just take that portion and say, sweet, plug it in, ta-da, done. Because it's still a limit, so you can still plug in. You just had to know which piece to plug it into. I mean, if you want to graph it and look, you could. Piecewise function limits? I don't think so. Slope of tangent lines, you guys know, talking about derivatives, right? Equation of tangent lines, you're doing point slope with the derivative value in, yeah. Oh, hey, discontinuities. Removable are holes. Non-removable are vertical asymptotes. So when I was saying on the quiz, no horizontal vertical asymptotes. Vertical asymptotes are the denominators, the zeros of the denominator that don't factor out, right? So number 70, what did you say, 3 or 4? Oh, you're welcome. 73, no denominator, so don't worry about zeros. No square root, so don't worry about complex numbers, aka negatives under the square root. No logarithms, so don't worry about vertical asymptotes. No trig functions, so don't worry about vertical asymptotes. Wait, so what's wrong with him? Nothing, he's good. I can multiply 3 times any number, it's still a number. I can take cosine, remember? He's good. I mean, he's annoying because he bounces back and forth, but as far as existing, he exists everywhere. So continuous. Derivatives, any questions that we have on derivatives? On the quiz, there are no multiple choice, so you can stick it to the man. What I mean by that is you don't have to simplify on the quiz since it's long answer. Does that make sense? Okay. That's when I say stick it to the man, it just means there's my answer, I'm done. Okay. Any derivative questions? Okay. Now we're down to, oh.
How do we know to use that gravity? Yeah, like I had to check your work first before I actually tried it because I was like.
Physics. What's acceleration of a free fall model? Gravity.
Oh, so it's gravity.
And I knew negative 9.8, not the negative 32, because it was meters, not feet. But you're not, remember, it might show up from time to time on the homework. I don't think it shows up. I try to keep it off of the tests because on the AP, you don't have to memorize physics formulas. Does that make sense? Including gravity. You guys are going to miss out on this whole, anyway, that's all right. I think we're good. Okay, what did I sacrifice? Polar parametric vectors. Why? It's not on the quiz tomorrow. Right? So then, I will check for total completion the packet on Thursday so that you guys have a little bit of chance after the quiz to ask me polar parametric if you need to. Sound good? Okay. Are we all on the same page? Get out of here. Quiz tomorrow. Bye. Thursday. Yeah. Yeah. Let's do Monday. That's okay. Yeah. Have a good trip. Good. Where are you going? What college are you visiting, Riley?
I'm going, so I'm
Doing
gonna
like a-
fly to Chicago.
Okay.
And look at like University of
Go
Chicago,
ahead.
a bunch of schools there.